Hello, angels. Welcome to today's math lesson. I hope you're all well, and I hope your family are all okay as well. So we're going to be continuing with our unit on decimals, fractions, and later on percentages. Your lesson objective today is to recognize and use thousands and relate them to tenths, hundreds, and decimal equivalents. What that simply means is using your decimal place value grid, you're able to recognize numbers after the decimal point, the numbers they come under in each column, and what they represent when you compare them to the numbers before the decimal. So the whole numbers, like your units, your tenths, and your hundreds. When we are looking at decimals, when we're looking at hundreds, we say them in the following way: 7.53, 9.39, or 4.70. You can actually say 7.53, and if you do, you haven't made a mistake, and that's okay. But another way to say it is 7.53. So you take all the digits after the decimal individually. Yesterday, we looked at decimals and also fractions and writing them in words as well. So I wanted to just recap from yesterday's lesson before we move on. So here we have my fraction in words, fraction in figures, decimal in figures, and decimals in words. So for the first one, we have 6 units, 8 tenths, 9 hundredths, and that's the same as 6 whole, 89 hundredths, and 6.89, and then of course decimal in words. So you can pause this video now, and then you can take a look at the rest of them. Another exercise I wanted you to try, which is bigger. Now, for some of you, you might look at these numbers and you can tell straight away which is bigger. And also for some of you, you might decide that you would like to use your place value grid to make it a lot easier for you. So let me grab mine. So here's one that I drew earlier. Not perfect, but it will do. Now, if you look at this, the first one says 1.12 and 12.14. Straight away, you can see that 12.14 is the bigger number. And then if you go to the bottom, we have 64.7, and then right here we have 63.75. Again, you can tell right away that 64.7 is bigger, but if you're not sure, this is where you use your place value grid to help you. So let's try a couple of them. 6.08. So I will write in 6.08. And then the number next to it is 6.10. 6.10, which is bigger. So we start with the number to the left, which is under the units column, and they're both 6. And then we move on to the number on the right, which is now the number after the decimal points. So we look at the tenths column, and the first number is a 0. And the second number has a 1/10 in the tenths column. So we know straight away, without having to look at the next column, that 6.10 is bigger than 6.08. So pause the video, use your decimal place value grid, and then work out which ones are bigger. So what is the relationship between tenths, hundreds, and thousands? So I've got my place value grid right here. If 4 tenths equals 0.4 and 4 hundredths equal 0.04, what is 4 thousandths equal to? So again, you get your place value grid to help you with this one. So we'll look at the first one, 0.4. So I write in 0.4. Next one, 0.04. 0.04. And then it says, what is 4 thousandths equal to? Now I go under my thousands column and I put 4, and then I can put 0, 0.0 to help me as a placeholder. So now let me number them so we know which ones we are working with. So the question again, what is 4 thousandths equal to? And I know that 4 thousandths is equal to 0.004. Okay. Again, this is very, very simple and easy to do. As long as you have your place value grid, you can put in the numbers, and then you can tell which number is in which column and what it represents. How do we read the following numbers? So pause this video and then try. A is 0.35, B 1.06, C 12.014, and D 2.13. Again, any numbers before the decimal is a whole number, and any numbers after the decimal are fractions, parts of a whole number. So pause this video so you can read this. Decimals. Decimal numbers represent numbers that are in between numbers. Numbers to the left of the decimal point are whole numbers, and numbers to the right are fractions or parts. When you count and go beyond 9, we use another place value to the left. This represents a number that is 10 times larger than the previous number. Our number system, base 10, can represent any whole number amount, no matter how big, by adding bigger and bigger numbers to the left. It can also represent in-between numbers, and these come after the decimal point. So, in a nutshell, what that simply means is this. Just grab my paper. Carry the number to the left. You can't write 10 in the column, and base 10 number system is what we use. So let me explain what all that meant. When we have numbers, so let's use the numbers to the left of the decimal. So we've got 235 here. When we start counting in the unit 5, 6, 7, 8, 9, 10, we never write 10. Instead, we write 0, and then we carry the 1 to the left, and as the number gets bigger. So that's what it meant when it says that numbers to the left are whole, and then when you count and you get to beyond 9, we use another place value to the left. And of course, that represents that the number is now 10 times bigger than what it was. We also do the same thing here. Just grab my paper. So look at the decimal. So here we have 1/10, 100ths, and 1,000ths. So in the tenths column, I have a 1. So if I was to count 2/10, 3/10, 4/10, 5/10, 6/10, 7/10, 8/10, 9/10, I'm not going to write 10/10 here. Instead, I will write 0, and then I'll carry that 1, and now it becomes a whole 1. So 10/10 makes a whole unit. Same thing here in the hundredths column. When you're counting 1/100th, 2/100th, and when you get to 9/100ths, you don't write 10/100ths. You write 0, and then you move the 1 to the next column on the left. So 10/100ths becomes 1/10, and then 10/10ths becomes a unit. Same thing here in the thousandths column. We count from 1,000ths, 2,000ths. When we get to 9,000ths, we don't write 10,000ths. We write 0, and then we move the number one space to the left, and it goes into the hundredths column. Same thing here. We have 900ths, but we don't write 10/100ths. We write 0, and then we move the number to the next column on the left. Exactly what you do when working with whole numbers. So here, for example, we have 5.991. So we count 1, 2, 3 thousandths, 4 thousandths, 5, 6, 7, 8. When it gets to 9, so if this was 9, for example, we don't write 10 because we don't write that way. We write 0, and then we transfer the 1 to the column on the left, exactly as we would do here. Yes, if this number gets to 9, this is now 9. When we get the unit gets to 10, we don't write 10, we write 0, and then we carry the number to the left of the column. So that's what we mean by when we say count and go beyond 9, we use another place value to the left, and this represents a number that is 10 times larger than the previous number. And of course, you all know that our number system is base 10. So here's a mathematical inquiry for you to do using your place value chart. So here we have the unit, and then we have the decimal point, then your tenths column, hundredths column, thousandths column. So I would like you to find out how many tenths do you need to make one whole? How many hundredths do you need to make 1/10? And how many thousandths are there in 1/100ths? So find out and then email us your findings, and we look forward to seeing them. So 1 whole is equal to 10 tenths. 1/10 equals 0.1, and 100 equals 0.01, which means that hundredths equal 10 hundredths. This is just mentioning what we've just seen, which is this paper. Okay. 1/10 is equal to 0.1, and a whole, 1 whole is equal to 10 tenths. So using my paper, here's one that I made earlier. So you have your 1, which is your units. I hope you can see that properly. That's better. Yeah, so you have your 1, which is the unit. This is the number to the left of the decimal. And then these are your fractions, your parts. So 1/10, these are your hundredths, and these are your thousands. I remember what we said. Where is that second paper? This one. Okay. 1/10, you need 10 tenths to make 1 whole. And then you need 10 hundredths to make 1/10. And then you need 10 thousandths to make 1/100ths. And then, of course, 10 hundredths to make 1/10, and then 1/10, 10 tenths to make 1 whole. And that's effectively what this diagram is, using bar models here. So you have 1 whole, and then you have your tenths, and then you have your hundredths. The bar model has been split, so each section is 10. So this is 10, this is 10, this is 10, and so on. And then you have your thousands. I'm sorry, the lines are not very clear here, but each box here is 100. That's 100, that's 100, that's 100, and that's 100, and so on. And that's similar to this. And I've got numbers down here, 369.198. The same thing. I'm on 8. If I was to have, so this is 8 thousandths, 9 thousandths. And when I get to 9 thousandths, I don't write 10 thousandths. I write 0, and I take the 1 to the next column on the left and then put it here. And if this is going to be a 10, I don't write 10. I put a 0, and I take the number and put it here to the left column, and so on and so forth. And I keep going. And remember, anything to the left of the decimal, they're whole numbers. So when you move towards the left, the number gets bigger. And as you move towards the right, the number gets smaller. Okay, so using your decimal place value grid, I would like you to pause the video and write these numbers in your place value grid. So 0.198, 0.5, and so on. So most of them are written in decimal form. I would like you to write them in and then also write them as a fraction and in Word as well. So go ahead and pause the video. Okay, so now you can go online and look for your task and complete, and then email and send it to us. And once you have completed your task, you also have word problems extra that I have given you. So you can either do this one first or your task. It's up to you which one you decide to do first. Complete them both and then email it back to us.